Hello and welcome to Slooh Space Camera's live Supermoon event. I'm Paul Cox. I'm talking to you from Slooh's Canary Islands Observatory. I'm actually 8,000 feet up on the top of a volcano at the observatory here, which actually means I'm the highest person in Spanish territory. But we're going to talk a little bit more about the observatory in a bit. But this is our Supermoon event. We've got some fantastic guests on the show tonight, as well as course, our real-time images of the moon coming from the telescopes I'm surrounded with. I'm sitting next to one of them right now. Now, if you've got questions at any point in the show, go to the Slooh homepage or YouTube, and our producer, Mr. Pat Palucci, he's going to be monitoring those, and he'll feed those questions into us. If you want to keep up to date with all of Slooh's live events, we do so many of them each week. You can look on the homepage, slooh.com, you can look at Facebook, you can look at Twitter or Google+, so all of the social networks. But listen, while we wait for the real-time feeds to come in, and I'll tell you they are looking superb tonight, the moon is looking fabulous, I want to tell you a little bit about where I am. This is Slooh's Observatory. It's in the Canary Islands, which is off the west coast of Africa in the Atlantic Ocean. And the reason why all of these fantastic world-class telescopes are at this site is because the air coming over the Atlantic Ocean is nice and smooth. And of course, it's a volcano. It's very high, 8,000 feet up in the air, so we're above most of the atmosphere, which really interrupts and blurs the view through telescopes. Now, these telescopes that we operate, the ones we're going to be using tonight to see the real-time images, these things, you can control them. I'm going to talk to you a little bit about how you can do that. And the first way is through our new iPad app. So if you've got, by the way, we make no apologies for doing a little bit of promotion for Slooh, because it's people using the iPad app, it's people joining Slooh, which enables us to put on these free public events for everybody. So we make no apologies for it. But listen, if you've got an iPad, you've got to download Slooh's free iPad app. It is so good. And I'm sitting right next, I mean, I am literally, my arm is up against it, a half-meter telescope at our Canary Islands Observatory. The iPad app enables you to single-click book a mission to actually control this and the other Slooh telescopes. We call them Slooh Space Cameras, and that's exactly what they are. So anyway, download the iPad app, book up a couple of missions, you will absolutely love it. It's also quite educational because it's like a kind of virtual sky, so you can kind of whiz around and you just find the object, book it, and Slooh, we schedule when that object is going to be best seen in the sky. But listen, if you haven't got an iPad, then there's another way you can control these telescopes, all of Slooh's telescopes, by normal membership. And you join up, $19.99 a month at the moment. Oh, we got a special offer as well that I've got to tell you about today. Just while we wait for the live images to come in, thank you for allowing me to do this. But listen, a Slooh membership enables you to control these telescopes from the comfort of your home. It's really easy to do, but these are really high-end scientific telescopes, so you know you're really controlling some fantastic stuff there. Now, what are we going to do? I've got to tell you, we have got this special offer, which you can see on your screen at the moment. If you join Slooh today, and this is a one-day only offer, we will send you this amazing kind of Slooh Kids activity book, which actually includes with it 200 minutes using the Slooh telescopes. So you can give that to son, daughter, nephew, whoever, even the kid down the block, right? And they can use the same telescope that you'll be using your Slooh membership. So please, join up for Slooh, download the iPad app, because it's those memberships that allow us to put on these live public shows, and that means that's exactly where we're coming to now. So thank you for allowing me to do that little bit of intro about Slooh, and it's time for me to introduce our first esteemed guest, and it's the wonderful Mr. Bob Berman. Slooh regular listeners will know Bob. He's an astronomy author. I call him the astronomy author extraordinaire. His most recent book is The Sun's Heartbeat. And Bob, you're talking to us, I believe, from Hawaii today. We've got a really global team joining us.
That's right. That's right. We went to Hawaii. This is the only place in which the supermoon could be seen at the moment in which it reached its closest point to the Earth, and also at the same time it was full. From the extreme westernmost continental United States, it was very low in the sky, but from Hawaii alone was it actually well seen and high up, and we observed it indeed. That was just a matter of some hours ago. Now, it is still a supermoon because it doesn't change from full to non-full in an eye blink, and neither does it go from its closest point to Earth of the year, which is what really made this extraordinary, to suddenly far away. So the closest point, 252,500 miles, is the nearest point to our planet. The smallest separation between the moon and Earth for all of 2013, and this occurred in the same hour in which it was full. It also occurred, of course, a mere 2 days after the solstice. So the coming together of all of these circumstances has produced a large moon, an influential moon, and the strongest tides we have of the entire year. Here in Hawaii, it's nothing less but spectacular. So while we see the images from the Canary Island, I know this is a group of people. Patrick Paolucci is controlling this from L.A. You are in the Canary Islands. We have Matt Francis in an observatory in Arizona. I'm here in Hawaii, where the supermoon, the only place where it was decently seen high in the sky, at least within the purvey of the United States. So it's really an international team as we're looking at this.
Now, Bob, we've got these live images coming in from the telescopes that are just around me. I've never done a show, actually, live from the observatory inside the dome. So it's pretty fantastic, all the technology that we use to do this. Now, just take a step back a minute. The supermoon, the media's been talking about it. You've just said there the moon's going to be about 222,000 miles away from the Earth. Why? Surely the moon just orbits the Earth and goes around the Earth, and it's always the same distance, isn't it? Why is it any different now?
Well, the real reason is that the moon's orbit is not a circle, but an ellipse. And not only is it oval, but it changes its shape. This is fantastic. So as the moon goes around Earth, it never returns to its starting point. Its orbit never really closes in on itself, but instead it forms a kind of rosette pattern. And on top of that, the shape of the ellipse becomes more stretched out, more elliptical at times. It actually does that when the Earth, the Sun, and the Moon form a straight line in space called syzygy. S-Y-Z-Y-G-Y. People say it's a Greek Scrabble word, but it isn't, because you need 3 Y's, and there's only 2 Y's in Scrabble. But never mind that. This changes the shape of the moon and allows the moon to come unusually close, and that's what has happened. And the moon, when we say unusually close, we're talking about 12 or 14% closer, but because brightness varies inversely with the square of distance, it means it's some 30% brighter than it is at other times. So it's a brighter moon, a bigger moon, a closer moon, which means the tides and the tidal force varies. I don't even know if you knew this, Paul, and you're very, very knowledgeable about astronomy, that tidal forces do not vary with the square of distance. They vary with the cube of distance.
No, I didn't know that one, Bob.
Yeah, so that a change in distance from one object to another influences tides the cube of distance. So there's a huge change, meaning if the moon should suddenly come 3 times closer to Earth, its effect on us in terms of overall gravity would be 3 times 3, or 9. But its effect on us tidally would be 3 times 3 times 3, or 27. So the tides on Earth would become 27 times stronger, and the average 3-foot tide that we see in the seas, normally the seas rise 3 feet. Near the shore, it's more than that. It's more like 5 feet, because tides get amplified when they get into shallower water. But out in the open sea, it's an average of 3 feet, would suddenly become closer to 80 feet of ocean going up and down if that happened with the moon. So it's a huge effect, and we're certainly seeing it here in Hawaii. And any of our viewers or listeners who live by the ocean and can consult the tide tables will see that the tides are, when they go out, they're exposing all those clams and all the ocean and all the areas that normally are still covered by water at low tide. And at high tide, it's coming up right to the boardwalk. It's really, really coming out. And that's today and even tomorrow, because the oceans really require about a day to catch up with the mechanisms of the Earth and the Moon. So today and especially tomorrow, we have these extraordinarily rich high tides. And so people who think that the Moon, which we're viewing now and showing you close up at Slooh, that it is some kind of so intellectual object, that astronomy is just a subject of something for geeks and nerds and intellectually. Here you can go out and see its actual effect on flooding, on animals, especially the animals that live in these intertidal zones, the marshes and saltwater briny areas that are exposed and then unexposed. And they're predators like gulls that depend on finding these crabs and other animals that are whose lives are tidally linked. So very much Earth's behavior depends on this, the Moon, and especially the supermoon.
Now, Bob, you talked there about people by the ocean being able to see the effects of the tide and stuff like that. I'd just like to tell everybody out there that although we're seeing these fantastic live views from the Slooh telescopes in the Canary Islands at the moment, we've got a high mag view there and also a full disc view as well. You can order, by the way, a supermoon image of your own if you use the iPad app. So please don't forget to do that. But Bob, what I wanted to say to people was, because I'm in the Canary Islands, which is obviously to the east of the United States, where a lot of our viewers are, although we have got viewers around the world tonight, if anybody hasn't reached their dusk wherever they live, please go outside around dusk and you will see a fabulous, fabulous sight. And I experienced it earlier here in the Canary Islands. I was looking down over to the east with this supermoon rising, and it was actually rising behind one of the other Canary Islands, which is basically a huge volcano crater. And it looked like this red orange moon was rising up out of the crater. We've got a picture of it that we're going to show you. Now, no picture can do this justice, which is kind of why I'm saying to you, go outside at dusk, whenever dusk is for you in the Northern Hemisphere, and you can go out and you can look at this beautiful moon rising. But, Bob, what you've got tonight is a kind of punctuated sky. Over in the east, you've got the supermoon rising. If you look directly overhead when it's dark enough, you'll see the ringed planet Saturn looking absolutely glorious. You won't miss it. It's the brightest thing above you. And then setting over in the west, you've got what looks like the brightest possible star, and in fact something that a lot of people report as a UFO, and it's Venus. And Venus from here in the Canary Islands has been looking absolutely stunning. Because I'm so high up, I actually see it set below the horizon, and it goes this beautiful red, deep red color. So there's an image that I took tonight. Bob, I don't know if you can see the images that we're sharing tonight, but there's the image I took about 2 hours ago, and you can see there in that image the supermoon in the background. The ocean is just below that, and there was this beautiful reflection in the ocean, and you can see there the telescopes that we're using during this event. So Bob, you know, although it's fantastic to look through telescopes, sometimes it's also great, isn't it, to look up in the sky and just feel really the connection that you were talking about earlier.
Absolutely. And just to advise people, and people who are knowledgeable about science so that we don't overhype this, yes, this is the closest moon of the year. Yes, it's occurring at the same hour that it's full, and indeed it's a solstitial moon. The name for this is a Perigean full moon, sometimes called a Proxygean moon, because the tides are so extraordinary when this kind of lineup happens.
I hadn't heard that term, Bob. What was that again? Say that again.
It's called either a Perigean full moon or a Proxygean. They call these Proxygean tides. These are the strongest possible tides because of this lineup of both a full moon. Full moon always produces higher tides called spring tides than than is normal. And then when the moon is at perigee at the same time, those will be particularly strong tides. But this is not just an ordinary perigee or close approach. This is the closest approach of the year and full moon. So you have it all happening together. Now all you need is one final element, like perhaps a storm at sea, and then you'll get flooding, because, or even a low pressure area, because each 1 inch drop of air pressure produces 1 foot of rise in the ocean. It's almost like the pool of mercury in the bottom of a mercury barometer. 1 inch of air pressure makes the ocean go up 1 foot. So if you have onshore winds, low pressure, and tides like this, then you can count on coastal flooding. But what I want to do, not to hype it, is to be honest, and that is the difference in the actual size of the moon today is only about 13% different from when the moon is farther from us. And the 13% change is pretty much on the edge of what you'd really notice. What you do see, however, is what you described, Paul, earlier, and that is when the moon is low near the horizon, and the moon will be rising just after sunset tonight, wherever you live. You don't have to give a clock time for it. Go out and face the opposite direction of the sunset, and you'll see the moon rising very soon after sunset. And that full moon, whenever it's low, always looks extraordinarily large, thanks to the famous moon
illusion effect. Yeah.
The moon illusion makes constellations look large. When Orion is low, it doesn't look like the same hunter as it does when it's higher. When the Big Dipper is low, it looks enormous. And the same thing happens to the full moon or any shaped moon. So we have the moon illusion, making the moon look large. We have this perigean moon, which means the moon actually is large, on top of it looking larger. And so we get a double whammy tonight.
I don't think,
extraordinary.
In all of my years of looking up and looking through telescopes and just looking at the sky generally, I don't think I've ever had the kind of sight that I had tonight, just looking at this enormous supermoon rising, and the fact that I see it coming out of the crater of this volcanic island just made it all the better. And we've got some photos that we'll probably put on the Google Plus stream on the Facebook page a little bit later. Now, everybody, we've got worldwide listeners and viewers tonight. We've still got stacks of really, really good programming and content and live images. We're going to invite our second guest in just a minute. But just before that, I want to remind you, if you've got any questions, please, you can put them in the on YouTube, you can put them on the Slooh homepage, and our producer will feed those in to the panel tonight. Now, don't forget, our live free public shows are made possible by people joining Slooh or using our free iPad app. Now, the app is free to download, and then you can book a mission. It really is as simple as pressing a button. Now, if you're new to astronomy, you know, astronomy can be a really daunting subject. The learning curve looks horrendous. But what we try and do at Slooh is we try and remove those barriers to the subject. And we all remember back when we first started and what a Herculean task it looked like. So you can start with Slooh, little steps. And what we do is we give you a top 10 recommendations each week. Now, please, in the iPad app, even if you've been using the iPad app, look at those top 10 recommendations. I put those together based usually on what's looking the best, and a lot of that actually has to do with moon phase, because when the moon's very bright, it doesn't really do very much good for imaging galaxies and faint nebulae and things like that. So the recommendations last week were all solar system objects. We've been looking, people have been booking missions and controlling the Slooh telescopes for Saturn images, for Uranus images, for Neptune images. Neptune with its moon Triton, that's what you get in one of these images. It's so cool, I'll tell you. And what you've got to be thinking about is, although we've made it really simple, you press that button in that app, but what you're doing is you're sending a control into the Slooh servers, and the Slooh servers work out when it's going to move the telescope and take your image, and then you get it fed back. So you always get the best possible image that you can get. But don't worry, if you haven't got an iPad app, you can still use the Slooh telescopes through a normal Slooh membership. And today we have got a very special offer. If you join up, it's $19.99 a month for normal Slooh membership, and you control in real time the telescopes I'm sitting next to. I'm sitting next to, underneath, this enormous telescope. It's 0.5 meter in diameter. This is a scientific class instrument. The camera stuck on the back is worth $15,000. I won't tell you what the rest of the kit's worth, but it would make your eyes water. So listen, have a look at this photo that I'm screen sharing in at the moment in the show. You can see the supermoon there in the background. Can you see there's a telescope on the left-hand side? That's what we call our planetary system. That's the one that looks fantastic for Saturn and things like that. But if you look just down at the bottom, you can see a kind of truss frame. That's the 0.5 meter telescope, and that's where I'm talking to you from right now. So anyway, please consider joining Slooh or using the iPad app, because it supports these live free shows. We're passionate about astronomy. We love getting astronomy out there to everybody. And that's a fantastic segue into my next guest, Mr. Matt Francis from the Prescott Observatory in Arizona. Now, it's a private observatory, and Matt is passionate getting science and astronomy out to the public, as we all are. And Matt, I don't know if you can hear me, but isn't that the reason why you set up the Prescott Observatory to start off with?
That's right, Paul. That was one of my goals I had with this facility. My desire went from just setting up a very private, small-scale telescope to take pictures of the sky to a very large-scale observatory that now has a dedicated solar lab, a nanotechnology lab, and a large dome with some very large telescopes.
Wow. Now,
yeah,
Arizona. Now, we're in the Canary Islands. We're high on this volcano because that's the place where telescopes should be, up above the atmosphere. So why are so many telescopes based where you are in Arizona?
Arizona is an excellent place for astronomy because it is higher elevation. I'm at 6,000 feet. Up in Flagstaff, nice. They're at 8,000 feet. And the air here is extremely dry, which makes for a steadier atmosphere, clearer seeing. Okay. So you've got a large also astronomy industry in Flagstaff and Phoenix and Tucson, where Kitt Peak is. So it's an excellent place for astronomy.
And I guess it's a sparsely populated area as well, so you don't have the kind of sky light pollution that people in towns and, in fact, most rural areas suffer from. I mean, people don't actually understand, do they, that they can go into a store, they can buy a telescope, but actually using it at home is next to useless, probably for 90% of the population, because looking up, they can hardly see any stars at all, just because of the light pollution, let alone you then pull into the equation the weather and the difficulty of using these kind of things. But so you often do solar shows for us, don't you? You provide our live images for a lot of the solar shows. So what have you got coming up next for us, Matt?
Well, as you know, the sun is at an activity high cycle right now, yep. And I was actually imaging the sun this morning for Slooh to upload the most recent pictures onto the app, and the solar disk is very, very active right now, and it looks like we had another M-class eruption on the solar disk today.
Is that what if people ordered on the iPad app, if they when we come back. But we're going to look we're going to be talking about manned space missions, and specifically with Bob Berman's going to be joining us again, the Apollo program. We're going to be talking about that. But before we do, we're going to give you a little bit of a rest from our voices, and we're going to show you a very quick video of Apollo 16. So please don't go away. We've got plenty of content. We've got our real-time live images coming in from the Canary Islands of this supermoon still. So we'll leave you for a short while, and we'll be back in a few minutes' time.
T-minus 25, 24, 23, 22, 21, 20, 19, 18, 17, guidance release, 15, 14, 13, 12, 11, 10, 9. We have ignition sequence start. The engine's now building up to 7.7 million pounds of thrust. We have a launch commit and we have a liftoff. The swing arm moving back. The Saturn V lifting off the alpha pad, building up thrust. We clear the tower. Houston is now controlling. Oh, we have good thrust in all five. Roger. Get your roll program started. Roger. 16 now moving to a proper flight path attitude. Mark 27 seconds. Seconds, roll program completed, pitch profile still in progress, 40 seconds. Mark 50 seconds, cabin pressure relieving, adjusting now from sea level to a space environment, 2 nautical miles in altitude. Cabin relieving, 1 Bravo. Roger, from 1 Bravo. You're wet now, 16. That call up from Capcom Gordon Fullerton says Apollo 16 now capable of water landing. Mark 1 minute 12 seconds coming up on period of maximum aerodynamic pressure on the vehicle. One minute 22 seconds, 6 nautical miles in altitude, looking good.
Wow. The three of us, we were going to take a little bit of a break when we showed you that Apollo 16 launch, but actually we were reminiscing. Isn't that a wonderful sight? We really missed that. There was something very special about those Saturn rockets. But listen, just before we go in to talk about manned spaceflight and missions to the moon, Matt, you're going to talk us through some of the images that you took of Supermoon yesterday. These are stunning images. What's this first one that you've got up?
So the first one is the Apollo 11 landing site, and this is actually one of my favorite pictures, because just to think of, when I was a kid and to see Neil Armstrong coming down the ladder and stepping off, and to think that he was right there. Every time I look up at the moon, it's impossible not to think of those guys.
I know. It's astonishing, isn't it?
I miss the days of looking forward to the next, human space missions. That who was going to go up next, and what were they going to do? I mean, even taking, back when we were taking cars to the moon. I mean,
I know, it's utterly crazy when you look back at it. No wonder people think that it was a hoax, because it is absolutely fantastic. It is extraordinary that we sent men to the moon. But we're going to talk about this with Bob in a second. 41 years ago, isn't it? The last man's footprint was made on the moon. There's something dreadfully wrong in the world if we've lost our sense of adventure and exploration. So, Matt, what's this second image? This is the crater Copernicus, isn't it? Which is very easy for people to see visually if they look up at the moon tonight.
Yeah, that's right, Paul. That is Copernicus, and it's one of my favorites because it has such fine detail that's just comes out so well in an astrophotograph. I think it's one of the most dramatic areas on the moon.
It is, and what I love when actually one of the things we were doing last week, we did a special. Anybody on the iPad app who ordered a lunar mission, a moon mission, we were doing these high mag close-ups, and it was amazing to see. You could kind of see one crater layered over the other, and the ejected material from one of the craters going over the other. So you could almost see the layers of impact kind of building up in these images. Now, what's this last one then, Matt? This is a stunning image. This is taken from your observatory at the Prescott Observatory, isn't it?
That's correct. This is just a close-up of the same Copernicus feature.
That is stunning.
As you know, Paul, you mentioned that sometimes it's better to look at things with your naked eye. And although this is very dramatic, these pictures, but when the moon is very full, it's actually hard to get good pictures because we don't have a lot of contrast with shadows coming across. But and the next one coming up here, this is Tycho. That's coming up, and that's also I like this one because you see the lunar limb, the south limb of the. You get to see some of the topography features, which is a nice.
It is wonderful. We were delivering some images last week into the app, which showed mountains on the lunar limb. We did a southern limb mission and a northern limb, and the detail that was in there was just absolutely stunning. In fact, we've got one coming up that we'll share with you. It was just a stunning image. And Matt, you're quite right. It's great having a picture of the supermoon, and if you people can order an image of the supermoon tonight. But if you really want to start seeing the detail of the moon, you need to be looking along the shadow line, to see all of these features, and they really come out. I mean, these are images from, I think, last week or the week before. Absolutely stunning. But anyway, listen, it is time to get Mr. Bob Berman back. Bob, you're still in Hawaii. You're still enjoying yourself down there. This is a real international team. We've got Matt Francis from Prescott Observatory in Arizona. I'm Paul Cox. I'm speaking to you from Slooh's Observatory in the Canary Islands. And Mr. Bob Berman, astronomy author, is speaking to us from Hawaii. Bob, Apollo program. Now, you've been doing a lot of research, haven't you, on the Apollo program over the years for various books and articles that you've written. What are the highlights of some of the stories from that period of time that you remember?
Quite right. And even though The Sun's Heartbeat is the book that we're plugging now, and that book puts out now, and that's about the sun, I did do a book some years back about the Apollo program and Shooting for the Moon. It was called, and it was my pleasure to interview a number of Apollo astronauts and really get some inside stories, including some things that the public still does not know that went on. For example, everybody knows that Neil Armstrong stepped down, and a lot of people know that 20 minutes later, when Buzz Aldrin stepped out, there was a little conversation between them when Armstrong said, and he's stepping out and making sure not to lock the door behind him. And and Buzz Aldrin said, yes, that wouldn't be good, would it? And I was thinking, come on, is this a comedy routine? Is this even possible for them to lock themselves out while they're both on the surface? Because originally the choreography called for the two not being on the surface together, because normally you don't leave your ship together. You always have somebody in charge. But it was decided it was actually safer with the buddy system to have them both out. But there were other difficulties. In any case, as Buzz Aldrin jumped down, because the lunar lander was a little higher up than they had planned. That's a whole other story why it was higher up. So the ladder didn't reach the surface. They had to jump down. As soon as
I've often wondered
that. Well, you know why? It was because Armstrong was such a darn good pilot. What he was supposed to do is the moment he saw the blue light come on that indicated that the contacts, there were contact probes on 3 of the 4 legs. And as soon as he saw the contact probe come on, he was supposed to kill the engine, and he was supposed to drop the rest of the way to the surface. But he flew it down right to the surface. So because of that, the honeycombed aluminum that made up the legs failed to compress from impact the way it was designed to do, and because of that, the ladder was higher up than it had been designed to be, and therefore they had to jump down. Now, they were jumping into shadow. On the moon, there's no scattering of the atmosphere, so the shadows are inky black. They could not see what they were jumping into, and Armstrong jumped down. It was pretty far. Unfortunately, because of the 160 of gravity on the moon, there's no consequence, but when a little higher up than when Buzz Aldrin jumped down, the urine bag in his boot broke from the impact.
That's what I love about listening to you, Bob. I always learn something new. I think that's probably the most unsavory new thing I've ever learned from you. But yeah, thank you for that. So what
he had a
next?
live mic. Well, he had a live mic, and he wasn't going to say anything to the world who was listening about, oh, no. But his hopping around on the moon could have been characterized as one small squish for a man during the whole time he was there. And I want to add something about, you mentioned that we did not go back to the moon, and one of the reasons we initially did not go back, that is that Apollos 18, 19, and 20 were canceled. It wasn't just because Richard Nixon hated the whole Apollo program. After all, it was his nemesis, the late President John F. Kennedy, who had famously made the Apollo program possible. You know, his famous speech of "we're going to go to the moon before the decade is out," and the media was still trumpeting and praising him, and Nixon hated the whole thing. So that wasn't the only reason he canceled the three final missions. It was also because of some wisdom, and that is, this is dangerous, going to the moon. And in fact, they just barely escaped a strong solar storm that could have given all of the crew fatal doses of radiation. And everybody knew, I mean, look at Apollo 13, that was a very, very close call, and everybody knew that each mission had things that could go wrong. And here were 6 successful landings on the moon, and thinking about it, they realized, look, right now it's a success. The public's not even paying attention anymore anyway. The media's not carrying it. The 7 o'clock news no longer is even carrying it. What do we have to gain versus what we have to lose with continued missions? Sooner or later, if we keep going, somebody's going to get killed. Let's cancel the rest and end the program in glory, where we can say we did it without ever having an astronaut lose their life. Or should we just do these final 3 missions, and maybe the Apollo program will be forever stained by tragedy?
Yeah. Well, I hadn't realized any of that, Bob. You know, I thought that it had really come to an end mainly because of public apathy. But, you know, this is relevant, isn't it, to talk about why the Apollo program ended at this particular moment in time, because there's been a lot of discussion over the last few years about returning to the moon, but probably more of the discussion has been about a manned mission to Mars, because although we can send these robotic rovers and things like this, which do provide a huge amount of information, you cannot beat a pair of human eyes and a pair of human hands when it comes to exploration. So, Bob, what are the main challenges to go back to the moon now? You know, we did it 40 years ago. Surely we could just kind of saddle up and go back there tomorrow. If we think the lunar lander, you know, had less of a computer than our mobile phones do, let alone a smartphone. And then also, what are the challenges about going to Mars? You mentioned the radiation there a second ago.
Yes, well, we've got, of course, radiation and the new RAD experiment, that is the newly released RAD experiment, that went aboard the mission that brought the Curiosity rover to Mars in April of 2011. That was an eye-opener. It showed us that the amount of radiation that would be received in a mission would be the same as getting a whole-body CAT scan every 4 to 5 days, which is about the same as getting being a Hiroshima survivor 1 mile from ground zero once a week for 6 full months. And that's not a small amount. It would increase your risk of cancer by about 4%. So it's not negligible. And that doesn't even count the time that the astronauts would spend on the surface of Mars, or what would happen if there was a major solar storm. There were no big solar storms during the Curiosity rover's trip to Mars. So we were really measuring galactic cosmic rays, that kind of radiation, not the solar radiation flux. So it is definitely, and the moon is the same thing, just as dangerous because it's outside Earth's magnetosphere and outside Earth's atmosphere. So should we jeopardize people and spend all the money relative to doing these things robotically? It's an old question of risk versus benefit.
Well, remind me, I must tell you something about the radiation and how they can shield for that. But I just want to remind everybody, we are watching these real-time images. Actually, this is a very rare occasion. These observatories are usually unmanned. We build them robotically, and members control them from around the world. From the comfort of your armchair, you can sign up for normal Slooh membership, which gives you a huge amount of control, book exactly when you want to book things, and it's maybe for more advanced people, but it's still pretty easy. Kids can use it, so you can join up, but also you can use our new iPad app, which is pretty cool. And the reason why I actually wanted to raise that now is that behind the scenes tonight is Patrick Pellucci. Patrick is the mainstay of Slooh. He's Slooh's president. And he produces these shows, and I'll tell you, it's a huge amount to put these shows on. It takes a huge amount of effort. And I was talking to Pat last week and saying, well, look, galaxies and nebulae aren't that great to image next week because the moon's at full of phases. So how can we make some interesting lunar missions? So anybody who books iPad missions to the moon this week which controls these telescopes to the moon and takes an image and feeds it back. You can see it on the screen now. That's what the app looks like, and that's one of the images that you get back. We were thinking, what can we do a bit differently? Well, we're going to do some high mag views. So really, like some of Matt's images that Matt showed earlier, you'll be able to zoom right in and get some of these things. But also, we're going to do a whole series of images, and we're going to announce these. So we'll say that if anybody books a moon mission today on the iPad app, your mission will run, and we will mark on it some of the Apollo sites. So we might do one on one day and another on another day. So you can build up. The app is absolutely fantastic at building up collections of your own images that you've taken yourself with the Slooh telescopes. One of my favorite collections that I've done with my iPad, I actually bought an iPad solely to use for Slooh, is collecting lunar phases, and it's fantastic. You can see it up there on the screen at the moment. Well, if you see the whole moon there, you just click on each one of your images that you've booked to control the telescopes to, and you can see the phase slowly growing and growing, and you also see the moon rotate slightly and things like that. But anyway, I just wanted to throw that in there, that keep an eye open. So for the recommendations on the iPad, we'll probably announce that on Twitter as well. So if you want the Apollo 16 landing site marked on the moon, book a mission today, that kind of thing. So anyway, listen, Bob, back to shielding. I learned something last week when they were talking about the shielding that they would require on a spacecraft for a manned mission to Mars. And somebody suggested, well, even if we could get it into space, surely we could just cover the spaceship in lead. But I actually learned something which I hadn't known before.
No, lead is not as good as plastic.
Well, the thing that I learned was the kind of high-energy particles in this radiation, if it was to hit lead, it would actually disintegrate and cause more radiation on the inside of the spacecraft than it actually held back. And one of the interesting things I heard was that water would actually be one of the best insulators. So that kind of got the engineer in me thinking about this kind of layered structure to be able, and they need a water source, don't they, on their long journey to Mars?
They need a water source, but we don't need water per se, and that's because what really does the trick for high energy cosmic rays, actually the highest energy, nothing is going to stop it, and you're going to get radiation exposure anyway. But what you want is hydrogen. in the compound that's going to do the shielding. And of course, water is 2/3 hydrogen, but so are certain types of plastic, lightweight, foamy type insulation. And it turns out that lightweight stuff does a lot better than even a foot of aluminum shielding to help the astronauts. So
well,
that's it might be doable.
Interesting.
But we know, as you said about the Apollo program, it was extraordinary that so few astronauts died in that whole program, and we know that there were some absolute tragedies in the early part of the program, and of course we've then got the shuttle program as well, which had its tragedies. But do you think a lot of our lack of exploration and our desire to explore has disappeared because we seem to be more risk averse in our lives nowadays?
It could be that, and it could be something else, Paul, entirely, and that is, we're on a budget. The world's on a budget, and we know that the amount of information that we can gather robotically for the buck, the dollar, for each dollar is far greater than keeping astronauts alive. On the other hand, there's a romance to the exploration, knowing that you and I may not be able to go, but here's a representative human being going, sending back reports, and above and beyond what the person might be able to do that a piece of the robotic equipment cannot, here is one of us as a service.
Lack of
that is similar to what happened to that poor simple medicine available, but not anything that could perhaps save someone's life if they were in an emergency situation. And how will we react if we see one or two of our crew there except for a premature and perhaps preventable end? Would that sour everybody on that? Would make people say,
That's interesting that you mentioned that, Bob, because I've said on a few Slooh shows that I've done in the past that even with my family, this might be one of the most selfish things ever, but even with a wife and daughter, if I had the opportunity of having a one-way ticket to Mars where I could be on Mars for 3 months, I think I'd take it. I really think
some people it would be because of their family rather than.
How about you, Matt? I know you're a bit of an adventurer. I mean, I think a few of us are pilots here. I do stunt flying and stuff like that. You do a lot of really courageous stuff as well, I know, as your hobbies and things. Would a one-way ticket to Mars be on your agenda?
That's a tough question, but I think I would say no. I as much as I would love to go there and pick up Martian soil and view the Earth from Mars, I don't think I'd want to leave my family earlier than I would need to. And that's the thing. We've got robots on Mars that are sending us images that are unprecedented in detail and view. And yeah, it would be a lot more to be there in person, but I don't think it's worth my life for 3 months of that adventure.
Well, I've already written a note to our producer, Pat Bellucci, to cut that segment out of the show where I said I would be prepared to leave my family and go to Mars for a one-way ticket. So, Bob,
now, Pat's the wrong person to ask because Patrick is so dedicated to Slooh and to science that, as we all know, to just improve the equipment, he has 2 lovely daughters, and he sold the oldest one into medical experiments to improve Slooh and its equipment.
This always happens. This always happens. We're in the last 10 minutes of the show, and Bob starts.
I'm sorry. What were you going to ask, Paul? You were going to ask me something. I'm sorry.
Yes. Let's get back. Let's pull ourselves back from the brink very quickly. Bob, just in case, Just in case anybody missed the beginning of the show, when we were talking about the main topic of the show tonight, the supermoon. Can you give a little brief recap? We're still looking at live images coming direct from the Canary Islands Observatory using the telescopes that anybody can control, either through the iPad app, the Slooh iPad app, which is free to download, and then you book missions. By the way, Bob does what we call an advisory each week. So Bob Berman, the objects that I pick, which are going to be the best things to image on in any particular week, Bob does a 5 or 10 minute advisory video that you can watch and listen to, and he tells you all about the objects that we've picked in our top missions. So do check that out, because in the app you can actually look at that. You can also watch our live shows and stuff like that. There's a lot more in the app than just booking the missions. If controlling robotic telescopes wasn't enough for you, then there's a whole stack of other stuff in there as well. So Bob, Supermoon, let's take a step back. We're still looking at these live images coming in from the Canary Islands. It's looking absolutely stunning. I'm looking above me now. I've got the dome open, the half-meter telescope looming over me, and I'm seeing this incredibly bright moon above me. Why is it so bright tonight? Why is it so big tonight?
While you're doing that, I'm here in Hawaii, of course, where the moon could be best seen at the moment that it was full some hours ago when it was at its closest point to Earth. And right now is high tide, and I'm looking at the effects of this, what is called a Perigean full moon, sometimes called a Proxygean full moon, as it completely covers areas of the coastline that are normally hidden. It's the effects of this moon are very dramatic. That's because we have the closest full moon of the entire year of 2013, where the moon is center to center distance, something that we're not going to see until next year again, happening during the same hour in which the moon was full. I might add also that it was just 2 days after the solstice. So we have an unusual lineup, which we didn't mention it earlier in the show. It also is producing the lowest full moon of the year. So tonight, whenever it's sunset...
That's for people in the Northern Hemisphere, isn't it, Bob?
Yes, for people in the Northern Hemisphere, as the sun sets tonight, a few minutes after sunset, you'll see that giant moon rising thanks to the moon illusion and the fact that it is larger than normal coming up. But even as the night goes on, you'll see that it will remain low. Instead of the moon attaining a normal height in the sky, the moon just won't get up very high. Even at its highest point, a little after 1 a.m. tonight, wherever you live, you'll see a low moon. And since low moons shine through more air and more moisture in the air, especially at this time of year, it's going to be amber, yellow, honey-colored. So we're going to have a true honeymoon tonight. More of a honeymoon than we've had at any other time of the year for a full moon.
It looked absolutely stunning, and when I saw it tonight, and I would urge everybody, we've been enjoying these live views of the supermoon tonight through the Canary Islands telescopes. By the way, with the live images of the moon have stopped, and I think it's showing... And the reason why we had to stop just in this last 10 minutes showing the moon is because of the way telescopes work. And they can't point when objects are in a certain position. And that is actually where the moon is. I'm looking at it behind me. It's due south to me at the moment. But I urge anybody, if dusk hasn't fallen, in fact, you can do this all week virtually, or certainly over the next couple of nights. Go out shortly after dusk, look east, and you'll see the wonderful moon rising. It's going to be getting smaller and smaller as the week goes on. But then, as darkness falls, look directly overhead, and you'll see a very, very bright object, and that's Saturn. And then look down on the western horizon, and the incredibly bright object looks like a bright star. That's the planet Venus. So it's really an absolute planetary solar system feast at the moment. And you can book missions. You can book images to Saturn at the moment. And it's still looking pretty good. All getting smaller, isn't it, Bob, Saturn?
It is. And let me just mention that it's only straight overhead for those in the well into the southern hemisphere. It's about 1/3 of the way up the southern sky for those in, let's say, Europe or the United States or Canada or such Saturn. And as for brightness, it appears about as bright or a little bit brighter than the star to its right. There'd be a blue star spica to its right. And so, yes, Saturn's quite nice. A little bit less big than it was on April 28th when it was at its very closest point, but I would say even more interesting now. Good reason to book a mission there, because the shadowing on Saturn, the body of Saturn is now casting a shadow on the rings in a way that we did not see a month and a half ago.
Yeah. It looks absolutely stunning. Bob, I'm going to come to you with a question in just 1 second. And the question is there any linkage between supermoon and the summer solstice? But just to remind everybody, we have got a special offer today. If you join Slooh, it costs $19.99 per month, and don't forget, we're not ashamed to promote Slooh during these shows, because it's Slooh members and it's people using the iPad app that enable us to do these free public shows. So I hope you excuse us doing this bit of promotion, but it's really necessary. But we've got this fantastic offer at the moment. If you join Slooh to control the telescopes every night, it's unlimited use. For $19.99 a month, we will send you a free kids activity book, which includes 200 minutes of using the telescope, which is totally separate to the membership that you bought. So you can give that to son, daughter, kids down the street, anybody, and they'll also be able to enjoy using the Slooh telescope. So, Bob, back to you on this last question as we round up. Is supermoon associated or linked to summer solstice, which occurred on Friday?
No, it just happens to have happened at that time, but the effect of it being so near the solstice, of course, is when the sun is highest in the sky for the year. The full moon is always opposite the sun, so whenever the sun is very high, the full moon has to be very low, and because this supermoon happened just 2 days after the solstice, that's why we have this very, very low full moon. It's not just big, it's not just near, it's not just affecting the tides in a very dramatic way, but we also have the reddest, most orange, most amber, honey-colored lowest moon of the year as well.
So we're going to round up our coverage tonight of supermoon. I hope you've enjoyed it. You know, the supermoon itself is, as you heard from Bob, it's an interesting set of coincidences, and it also has some fairly large impacts on the tides. So that was fascinating to listen to. But I hope too that you enjoyed some of Matt Francis's images from his Prescott Observatory in Arizona. They were absolutely terrific. And don't forget, we have a full lineup of live shows here on Slooh. You can view them from within the app, or you can view them on the Slooh homepage, or on the YouTube channel now as well, because Patrick Pellucci, our producer, any last questions before we wind up the show tonight?
Well, I'm just looking forward to going out and looking at the supermoon rise. As you know, my moon doesn't rise here until after 8 o'clock, and this broadcast started at 6, so I took some pictures yesterday of the moon rise, and as soon as we hang up, I'll be going out to watch it again tonight.
Well, maybe we can share them, and we'll compare some of the ones that you took with some of the ones that I got here in the Canary Islands. So, and Bob, you've joined us all the way from Hawaii. You know, you're over there, I think, for a bit of R&R, but it was very kind of you to join us from over there. The technology. Imagine this: Matt's in Arizona, Bob's in Hawaii, Patrick Pellucci, the producer, he's on the west coast of America, I'm in the Canary Islands, and we haven't had any tech issues tonight. Absolutely amazing. Bob, any last observations for us on this fantastic supermoon event tonight?
Oh, it was a lot of fun to be here and watch at the moment it happened, and to see Slooh's superb coverage, and see right now where I am standing. I am watching this extraordinary high tide as it's covering parts of the shore that normally never get covered at high tide. So this is a moon that's not just something cerebral and interesting and intellectual, but that has reached down to actually touch the earth and its citizens.
Well, thank you very much for joining us tonight, Bob, and we'll let you go and dry off your feet, and hopefully enjoy the rest of your breakdown there. Now, please check out the Slooh homepage, and you will see events counting down all the time. Thank you to Patrick Pellucci tonight, our producer, who's been doing a fantastic job behind the scenes, keeping the show running, doing all the PR for us. So I would just like to give one last thank you. And it's the biggest thank you of the night, and that is to Slooh members, because they've given up telescope time so that we could bring you live images of the moon tonight. And it's their memberships and it's people using the iPad app which enable us to do what we're passionate about, which is to bring live astronomy free to the public. So on that last note, thank you to Slooh members. It's Paul Cox, it's been Matt Francis, it's been Bob Berman, it's been Patrick Pellucci on the West Coast, all for Slooh Space Camera. We hope you enjoyed the live views tonight, and we hope to see you very soon. Good night, everybody.
Good night, guys.
Intro about Slooh, and it's time for me to introduce our first esteemed guest, and it's the wonderful Mr. Bob Berman. Slooh regular listeners will know Bob. He's an astronomy author. I call him the astronomy author extraordinaire. His most recent book is The Sun's Heartbeat. And Bob, you're talking to us, I believe, from Hawaii today. We've got a really global team joining us.
That's right. That's right. We went to Hawaii. This is the only place in which the supermoon could be seen at the moment in which it reached its closest point to the Earth, and also at the same time it was full. From the extreme westernmost continental United States, it was very low in the sky, but from Hawaii alone was it actually well seen and high up, and we observed it indeed. That was just a matter of some hours ago. Now, it is still a supermoon because it doesn't change from full to non-full in an eye blink, and neither does it go from its closest point to Earth of the year, which is what really made this extraordinary, to suddenly far away. So the closest point, 250.
It's people using the iPad app, it's people joining Slooh, which enables us to put on these free public events for everybody. So we make no apologies for it, but listen, if you've got an iPad, you've got to download Slooh's free iPad app. It is so good. And I'm sitting right next, I mean, I am literally, my arm is up against it, a half-meter telescope at our Canary Islands Observatory. The iPad app enables you to single-click book a mission to actually control this and the other Slooh telescopes. We call them Slooh Space Cameras, and that's exactly what they are. So anyway, download the iPad app, book up a couple of missions. You will absolutely love it. It's also quite educational because it's like a kind of virtual sky, so you can kind of whiz around and you just find the object, book it, and Slooh, we schedule when that object is going to be best seen in the sky. But listen, if you haven't got an iPad, then there's another way you can control these telescopes, all of Slooh's telescopes, by normal membership. And you join up, $19.99, many of them each week. You can look on the homepage, slooh.com. You can look at Facebook. You can look at Twitter or Google+. So all of the social networks. But listen, while we wait for the real-time feeds to come in, and I'll tell you they are looking superb tonight. The moon is looking fabulous. I want to tell you a little bit about where I am. This is Slooh's Observatory. It's in the Canary Islands, which is off the west coast of Africa in the Atlantic Ocean. And the reason why all of these fantastic world-class telescopes at this site is because the air coming over the Atlantic Ocean is nice and smooth. And of course, it's a volcano. It's very high, 8,000 feet up in the air. So we're above most of the atmosphere, which really interrupts and blurs the view through telescopes. Now, these telescopes that we operate, the ones we're going to be using tonight to see the real-time images, these things, you can control them. I'm going to talk to you a little bit about how you can do that. And the first way is through our new iPad app. So if you've got, by the way, we make no apologies for doing a little bit of promotion for Slooh, because a month at the moment. Oh, we got a special offer as well that I've got to tell you about today. Just while we wait for the live images to come in, thank you for allowing me to do this. But listen, a Slooh membership enables you to control these telescopes from the comfort of your home. It's really easy to do, but these are really high-end scientific telescopes. So, you know, you're really controlling some fantastic stuff there. Now, what are we going to do? I've got to tell you, we have got this special offer, which you can see on your screen at the moment. If you join Slooh today, and this is a one-day only offer, we will send you this amazing kind of Slooh Kids activity book, which actually includes with it 200 minutes using the Slooh telescopes. So you can give that to son, daughter, nephew, whoever, even the kid down the block, right? And they can use the same telescope that you'll be using your Slooh membership. So please, join up for Slooh, download the iPad app, because it's those memberships that allow us to put on these live public shows, and that means that's exactly where we're coming to now. So thank you for allowing me to do that. Hello and welcome to Slooh Space Camera's live Supermoon event. I'm Paul Cox. I'm talking to you from Slooh's Canary Islands Observatory. I'm actually 8,000 feet up on the top of a volcano at the observatory here, which actually means I'm the highest person in Spanish territory. But we're going to talk a little bit more about the observatory in a bit. But this is our Supermoon event. We've got some fantastic guests on the show tonight, as well as course, our real-time images of the moon coming from the telescopes I'm surrounded with. I'm sitting next to one of them right now. Now, if you've got questions at any point in the show, go to the Slooh homepage or YouTube, and our producer, Mr. Pat Palucci, he's going to be monitoring those, and he'll feed those questions into us. If you want to keep up to date with all of Slooh's live events, we do so many